did I get Maddie up there? All right, so those of you at home, can you hear me okay? Good. Can you also see my whiteboard? So we're going to take notes, boys and girls, in class. A little? Okay, yeah. So once I start writing, you should be able to see it a little bit better. Okay, so boys and girls, what I need you to do is open up your rubric. So those of you at home, open your rubric to the side. Those of you here, open up your rubric. And we are going to discuss what your essay needs to include. So who can tell me some of the things that you need to write about for your essay? Yep. Density. Density is one. Okay, what else? Oh, sorry, you guys can't see what I'm writing. All right.
Do I have to write about buoyancy?
Yes.
Remember, so the rubric is right on Google Classroom.
Buoyancy. What else? Pascal's principle.
The Charles law.
Not Charles.
Boyle.
Yes, Boyle's law. I started writing six.
And then Pascal's principle.
Yeah, if you drop my pencil.
And pressure.
You need a new pencil? Okay.
Pascal's, Boyle. And what else? And pressure. Here's another thing. Yep. And being what?
Oh, being compressed.
So I'm just going to write compression, matter. Compressed. Anything else? Anything else needs to be included? It's on the board. It's on your computer. Okay, so this is everything that needs to be included. I said we're going to break it into 2 paragraphs, right? So how are we going to break it up? What is each paragraph going to include? The chemistry and then physics. Chemistry and physics.
Me too.
All right. What's the overall question we're trying to answer?
How does it work? How does the thing work?
Right. Why does the Cartesian diver work? All right. So what are some good ways to start a paragraph that would answer this question? Anybody? Has anybody started their essay?
I did.
I made a whole essay, but now I have to delete it and do all this stuff.
Okay, so how do we start a paragraph? How do we start an essay? Thank you. I'm going to go with what Summer's saying because you guys are all. Thank you for participating. I just hear a lot of people talking. So we are going to reword the question and then include the answer in it. So how would I reword this question? So the Cartesian diver works by or because. Okay, right? Do we all agree? All right, so what are some of the things that we could write afterwards? The Cartesian diver works because... Why does it work?
Because of the compression of air inside of the
Density.
Okay, so density, compression of air. So we can take it where we just list everything.
Yeah.
We could also say that it works because of chemistry and physics concepts. What happens to make it work? What do we have to do? And then what happens? Okay, so it works because when you apply pressure to the outside of the bottle, the pipette will then be compressed and sink, and then when you release your pressure, it goes up. That's several ways to start your essay. Are we all okay with that so far? All right, let's break down each of these concepts now that you've been working with them for a little while to help you understand them a little bit better and how to apply them. So first of all, we have, what is buoyancy?
Water gravity.
Okay, and what's happening? Ava?
Ability to float.
Ability to float.
Write this stuff down.
All right, so that's really just telling us that the pipette is floating when we mention buoyancy. So using the definition and then explaining that the pipette's floating because of buoyancy is how you're going to include that, right? What's density?
Hot and cold water.
Well, what about hot and cold water?
How much it weighs? The weight of it.
Okay, what's another word for weight? We're not using weight in science. What are we using? I heard it. Mass. So density equals mass, but it's not just mass. What else?
How much mass is in a given space? What's another term for like
Propulsion.
I'm
recording
myself. Yeah.
What else? What's the other thing?
Say it again.
You said it. Brandon, what is it? Volume. Thank you. So density is equal to mass over volume. All right, we all have that written down somewhere? So let's put this to the side for a minute and see how that helps explain why the diver works. Well, what does density tell us about an object? If something was more dense than water, where would it go, Ava? Sink. And if something was less dense than water, it would float. If it had the same density as water, it would stay right in the middle, right? It would just kind of, so I've had a few people so far be able to do that with their fish tank. With the fish tank, just have their pipette floating in the middle. So they need to do what to the pipette to get it to float? Summer, what do you think? So if it's neutral density, if it's right in the middle, it's the same density, Mackenzie? Have a little bit less water in it, and then it would float, right? The more water, the more dense it is, the more it's going to sink. Okay? Are we all good so far? All right. Let's look at these other concepts that we just learned about. So we have Pascal's principle and Boyle's law. Let's start with Pascal's principle. So Pascal's principle, you guys did a small simulation. It had a container that looks kind of like this, and we were able to change the size, right, of each side. But you guys notice that it was a closed container? It was a tube. So was fluid getting in and out, or was it sealed inside?
Sealed inside.
Sealed inside. It was a closed container. And then I asked you to look up a picture. Did most of you find a picture that looks like this? Yeah. All right. That's my car. All right. And then if you looked closely, it usually said like times 10. So what that's saying is this pressure, when it's applied to one small part, is multiplied throughout the entire container. This is how a hydraulic lift for a car works. If you guys ever go with your parents to get your oil changed, this is how that they're able to lift a car up, is with a hydraulic lift. They apply pressure to a small part. It gets magnified, distributed throughout the entire container, and is able to raise that car. We're going to take this image and straighten it out to make it look like our soda bottle. All right, so if I just kind of like this, I now have
That's the 810.
this. You guys see that? In your head. Times 10. All right, so we have our water up here at the very top. It should be sealed. I've had a lot of students ask me why their diver isn't working, but they're forgetting to put the top on. If the top's not on the bottle and I squeeze the bottle, what's going to happen?
The water goes.
Right, we're going to have a giant like geyser, right? It's going to flow it's going to go all over the place. All right, what's inside of my soda bottle that we're putting inside? All right, pipette with the hex nut on it. Thank you. The hex nut helps add a little bit of weight, a little bit of mass, so it increases the density a little bit. Because the pipette, when I put it on top of the water, what is it going to do with no water inside of it? It's going to float. It's very buoyant, very little density, right? So we need to kind of help balance that out. So we put the hex nut on. What else do we do with the pipette? We cut it. What else? We fill it with water. Do we fill it to the tippy top with water? No. We go about 1/3, between 1/2 and 1/3, and it depends on how much other stuff you put on the pipette, right? We all good so far? Is my water going to be at the top or the bottom of the pipette? Bottom, because it's more dense. So here's my water. What's this at the top then, this not water area? Air. And what is air? A what?
Gas.
Thank you. All right, what is the rest of the bottle filled with? All right, I'll go with H2O since that's what we said. Hopefully you guys know what H2O is by now. All right, so we have learned that if I apply pressure to a small part of a closed container that has a fluid in it, so let's say I put my pressure here, what happens to the rest of the container? If I apply pressure to a small part, what happens to the rest of the container? What happens to the pressure? Increases. Thank you. We don't know if it's 10 times. It's going to depend on the rest of the size of the bottle. So pressure here means that is it just in one, is it the pressure increase just in this one area or over the whole bottle?
The whole bottle.
The whole bottle.
I guess we were trying to write.
All right, well, you're going to have to watch the video or come up. Right now, let me just help everybody. All right, so if the pressure is increasing and distributing through the entire bottle, what else is being affected other than the bottle? The pipette. What's happening to the pipette?
It's squeezing.
It's sinking because it's squeezing. All right, going back to this really quick, matter being compressed. Did you guys all look up the 3 states of matter and how they can be compressed?
Yeah.
What can be compressed? Which state of matter can be compressed? Gas. What else? What about liquid?
Yeah. No.
No. What about solid?
No.
No, their molecules are so close together we can't really compress them. But we saw with our Boyle's law simulation that we can compress gas. We're going to hold this for 1 second. Let's go over here, Boyle's law. Boyle's law looks like this, right? And there are these particles inside, and then what do?
Add pressure.
We added pressure by adding what?
Weight.
So we added weights on top, and every weight that we added made the lid go down, right?
Yeah.
So what happened to this area here?
It started to get tighter.
It got tighter, smaller and smaller, right? The more weights we added. So the molecules got pushed in a smaller area, right? So what changed when we added pressure? So increase of pressure made what happen? What was it? The molecules got closer together, but what decreased?
Pressure.
No, the pressure increased.
Yes.
Thank you. So the volume decreased. Pressure increased, volume decreased, right? Pressure increased, so what's going to decrease? The volume of
Air. Gas.
gas. Is the volume of the liquid going to decrease? Is the volume of the liquid going to decrease?
No.
No. So, Boyle's law is showing us that if pressure goes up, volume goes down.
Yeah.
Pressure goes up, volume goes down. So now it's my thing because I have the screen pacified on. So hopefully you guys are okay listening to this. So volume is now going down. What other equation has to do with volume that is important to explain why this works?
Pascal. Density.
Density! Density has to do with volume. If I'm squeezing my pipette, am I doing anything about the mass? Am I changing the mass? Am I changing what it's made up of because I squeeze it? No, the mass is the same. But if I squeeze it and it gets smaller, what am I changing? The volume. So let's think about this. If I drop my pipette in the water, it has 1/3 of water in it and 2/3 air, right? With my hex knot, pipette, whatever. And I don't do anything. I'm just going to make up these numbers. These are not real numbers. It's just so you guys can visualize to understand what's happening. Let's pretend my mass is 1 gram. My volume is 2 milliliters. What is 1 divided by 2 in decimal form?
0.
Thank you. So that equals 0.5. I'm going to leave out the units just so you guys can see the numbers, okay? Let's pretend I squeeze my bottle. How does my mass get affected? How does my mass get affected if I squeeze my bottle? Does it? No. So what's my mass going to be? 1. I was hoping I had a different color, but I guess not. If I squeeze my bottle and the gas gets compressed, but the water stays the same, what's going to happen to my volume inside the pipette?
Smaller.
It'll get smaller. What's a smaller number than 2? That would be 1. Okay. Easy math, right? Let's not go crazy here. What is 1 divided by 1 equal?
1.
1. Oh my goodness, guys. I need to send you back up to assist. All right. Looking at these 2 numbers, before I squeeze my bottle, after I squeeze my bottle, which one would have a bigger density? The one on the bottom, after I squeezed it. It changes the density to the point that it is more dense than water and makes my pipette sink. Do you now see how all of these concepts help explain how the Cartesian diver works?
Yeah, actually, I do. I'm glad to know.
Did we talk about density?
Yeah.
What happens to make the density change?
The pressure goes up.
The pressure increases, making the volume decrease, but the what stays the same?
The mass.
Excellent. Did we talk about buoyancy?
Yeah.
Yes. Is the pipette buoyant at first?
Yeah.
What happens after you squeeze it, Nad? It is not as buoyant, right? It changes its buoyancy. It sinks. Did we talk about Pascal's principle? Yes. Do we understand how in a closed container, when we apply pressure to one area, it gets magnified through the whole container?
Yeah.
Therefore, the pipette inside also gets that pressure applied to it. Did we talk about Boyle's law?
Yeah.
Yes, because when we apply that pressure, the pressure gets increased on the gas. So if pressure increases, volume decreases, going back to explaining how the density changes, making the diver sink. Did I mention pressure enough yet?
One last thing. Pressure increases, volume decreases.
Yes. And whose law is that?
Pascal? No, wait, Boyle.
Thank you. Who has questions right now about any concepts? Yes. Who else has questions about any concepts?
We still might need help figuring out everything.
And
Like what?
What would be like helping like kind of put everything?
Okay, so since there's no questions, I'm gonna stop the.
Do you feel better now?
Screen
Like
pacifier.
right in your head there?
yeah, I mean, I'm gonna have to like delete everything, but yeah.
It's just gonna be bad.
I mean, I'll have to delete everything.
I don't remember said. I wonder what.
Pascal.
All right, I don't know why I can't stop it right now. So those of you online, who needs help now with anything? Yes. So everybody at home is good? Nobody has any questions at all? Okay. I'm just trying to stop the screen pacify. I don't know why it's not stopping. All right, so if nobody has questions, I don't want to take more time away from you guys. You can go ahead and sign off and get to work. You should know what you're working on. You are presenting on Thursday in class. You're welcome. Bye.